Welcome back, class. I hope nobody had trouble with the homework. Are there any questions that I can answer?
I have a question. Why is Bones wearing that ridiculous hat?
Leave him alone, Tom. Bones, I like your hat.
Thanks. I just felt like celebrating. Today's my birthday.
Happy birthday, Bones. How old are you turning today?
143.
Me too. I'm almost 143 in werewolf years.
Am I the only one in this class who's just 12?
Class, let's refocus on some numbers that aren't our ages. We said in an earlier lesson that there are 3 different ways to write a quadratic equation. We already learned the first one, called standard form, so today we're going to learn the second way, called factored form, also known as intercept form. I'll explain later why it has 2 different names, but it makes perfect sense that one of those names is factored form, since it's a way of writing quadratic equations so that we can see their factors. So let's start by making sure we remember what factors are in math. Factoring means breaking up something bigger into the smaller pieces that make it. For example, how would we factor the number 6?
Factors of 6 would be any numbers that multiply together to equal 6. 2 times 3 equals 6, so 2 and 3 are factors of 6. Correct, teacher?
Right, Wendigo. So we can rewrite 6 in a factored form as 2 times 3. But what if we had to factor a whole quadratic equation like this one? This is written in standard form, where it's 3 ingredients, some x squareds plus some x's plus some number at the end, are written down in that order. How could we rewrite this as 2 factors times each other? We rewrote 6 as the product 2 times 3, but it's hard to see what the factors of a quadratic equation could be. What 2 things could we multiply together to get a bunch of x squareds and x's and a number at the end? Well, I'm going to show you. When we rewrite this equation in factored form, or intercept form as it's also called, this is what it looks like. For right now, don't worry about how I figured this out. We'll learn that later. For right now, just notice that this is what a quadratic equation looks like when we factor it. This is what its factors look like. The 2 things we're multiplying times each other are this x plus 2 part and this x plus 3 part, which means that x plus 2 is our first factor and x plus 3 is our second factor.
But, Mr. Caldwell, what does this mean? X plus 2 times x plus 3. This is not like 2 times 3 equals 6. 2 times 3 is easy. Everybody can multiply simple numbers like those. But how in the world are we supposed to multiply x plus 2 times x plus 3?
Good question, Tom. How do we multiply 2 quantities like x plus 2 and x plus 3 times each other? We call these things binomials, meaning 2 math terms combined together, like an x and a 2 being combined in the quantity x plus 2. So how do we multiply a binomial times a binomial? Some of you may have learned a technique called FOIL earlier in algebra. FOIL is our secret weapon for multiplying binomials like these. Let's review the FOIL technique because it's definitely handy when we work with quadratic equations. The technique works like this. FOIL stands for 4 words: first, outside, inside, and last. Each word helps us remember a step in the process. Each step involves multiplying a part of one binomial times a part of the other binomial. FOIL helps us remember which 2 terms we multiply in each step. The F stands for first, which means that our first step is to multiply the first term of x plus 2, which is just x, times the first term of x plus 3, which is also just x. X times x is x squared, so we write that down and move on to the next step in FOIL. The O stands for outside. We multiply together the 2 outside terms, the x at the beginning of x plus 2 times the plus 3 at the end of x plus 3. X times plus 3 gives us plus 3x. Now, we already had an x squared from the first step in FOIL. Now we have plus 3x from our second step in FOIL. The third step is the letter I, which stands for inside. We multiply together the 2 inside terms that almost touch each other in the middle of our factored form. That's the plus 2 at the end of x plus 2 and the x at the beginning of x plus 3. Plus 2 times x gives us plus 2x. Last of all, we do our L step, which stands for last. we multiply together the last term of x plus 2, which is plus 2, times the last term of x plus 3, which is plus 3. Plus 2 times plus 3 gives us plus 6. So the 4 steps of FOIL have given us x squared plus 3x plus 2x plus 6. The plus 3x plus 2x in the middle add up to plus 5x, so our final answer is x squared plus 5x plus 6.
Ah, I see. That is the very same quadratic equation that we started with. Y equals x squared plus 5x plus 6.
Therefore, the factored form is equivalent to the standard form. You have proven that they are the same.
Exactly, V9. By using the FOIL technique, we can see that standard form and factored form are really just two different ways of writing the same quadratic equation. We can also see that binomials, like x plus 2 and x plus 3, really do multiply together to create a quadratic equation. The factors of a quadratic equation are usually binomials like these.
Hold on, Mr. C. I don't get it. I mean, I understand how to do FOIL, but why would we want two different ways of doing exactly the same thing? I guess what I'm asking is, why are we learning this?
I believe it is not just two ways of doing the same thing. In my homeland there is a story. Two travelers in the darkness of night encounter an animal. One traveler feels the animal's head in the dark and says, "This animal has horns, so it must be a bull." The other traveler feels the animal's hair and says, "This animal has fleece, so it must be a sheep." It is only when they combine what they have learned that they understand what the animal actually is, a buffalo. The lesson is that sometimes it is good to have different ways to see the same problem.
Or maybe the lesson is that the first traveler was correct and this whole story was a lot of bull-aloney.
Ruby, I understand your point, but Wendigo is right. Sometimes in math, a new perspective shows us something we didn't notice before. In fact, we're about to encounter a good example of that. One thing that factored form shows us, which standard form doesn't show us, is what the factors of a quadratic equation are. But it does more than that. Factored form also shows us something we might not notice otherwise, unless we had a graph of the quadratic equation. Let's see what it is. Let's graph our original equation in standard form. Y equals x squared plus 5x plus 6. We get this. Does anyone remember what this shape is called?
I believe it is called a paradracula.
You mean a parabola, Tom?
Yes, that's what I said, a parabola.
A parabola dips in one direction, turns around, and goes back in the direction it came from. It can be shaped like a U or like a rainbow, but no matter which way it goes, this kind of boomerang shape means that a lot of parabolas cross the x-axis, then turn around and cross the x-axis again on the way back. So a lot of parabolas have two crossing points, two x-intercepts as we call them. Knowing what these x-intercepts are, where they're located, is going to be very helpful to us in a later lesson, but for right now let me give you an idea of why. If I gave you a quadratic equation and asked you to graph its parabola, you might wonder where to start. Knowing 1 or 2 points on a parabola is almost never going to be enough to graph the whole shape, because parabolas bend around so much and change direction. But it would help a lot more if I also told you where that parabola crossed the x-axis, in other words, where those x-intercepts were. Then you could start to graph the parabola because you knew where it was located and you would have an idea of its size. Well, that's what factored form does tell us. It tells us where the x-intercepts are. That's why I kept saying that factored form has another name, called intercept form. Watch this. The graph of our parabola crosses the x-axis at -2 and -3. Now look at our quadratic equation when we write it in factored form, also known as intercept form. It's y equals x plus 2 times x plus 3. Do you notice anything? Try something. Take our two x-intercepts from the graph and plug those x values into the equation. Plug -2 and -3 into our equation. What happens? If we plug in -2, the first factor becomes 0. If we plug in -3, the second factor becomes 0. Either of these two numbers will zero out our whole equation, because if either factor equals 0, then 0 times anything else will also be 0. In other words, when we write a quadratic equation in intercept form, also known as factored form, we can see right away what the x-intercepts of the graph are going to be. They're the numbers we can plug in for x that will turn either of our factors into 0, making y equals 0.
Therefore, intercept form is not redundant. It says the same thing as standard form, but in a different way that is useful.
Okay, I think I get it now.
Good. Now one last detail. Remember from our earlier lesson what a quadratic equation is made of. It's some x squareds added to some x's added to some plain old number at the end. All quadratic equations contain those three ingredients. But no two quadratic equations necessarily have the same amounts of those three ingredients. So we say that standard form for all quadratic equations is y equals ax squared plus bx plus c, where a just means some amount of x squareds, and b just means some amount of x's, and c just means some number added at the end. Well, the same thing is true with factored or intercept form. Different quadratic equations are going to have different factors. One might have x plus 1 and x plus 2, while another might have x plus 8 and x minus 10, and so on. So once again, we use letters to stand in for numbers. We say that the factored or intercept form for all quadratic equations is y equals x minus p times x minus q. P and q just stand for the tons of possible numbers that could go in those factors. Notice, though, that p and q are not just the numbers we see inside the factors themselves. They're the numbers we need to plug into those factors to get 0, because that's what gives us an x-intercept. For instance, if we have the quadratic equation y equals x plus 1 times x plus 2, then p and q are not the plus 1 and plus 2 that we see inside the factors. P and q are the numbers that we would plug into those factors to get 0. So p is negative 1 and q is negative 2. Again, p and q are the x-intercepts, the numbers that zero out our equation and make y equal 0. One last note about intercept form. Sometimes you might see me write another letter in intercept form, a lowercase a. But you don't really need to worry about that letter a. We're only going to use it if we run into a quadratic equation that starts with a multiple of x squared, like 2x squared, or 3x squared, or 4x squared, because the lowercase a will stand for whatever number we multiply x by. Most of the quadratic equations we're going to work with start with plain old x squared, not a multiple of it, so the lowercase letter a won't affect us. Alright, I know we covered a lot of material today, so I'm going to ask you some questions to make sure you understand it. We'll start with you, Ruby. In an earlier lesson, we learned how to write quadratic equations in standard form, but today we learned to write them in what other form?
It has two different names, right? We can call it factored form or intercept form, and it's just a different way of writing the same quadratic equations we have been writing in standard form, so that we can see them in a different way.
Exactly right, Ruby. V9, here's a question for you. We said that when we factor a number, like the number 6, its factors are also numbers, like 2 and 3. But what do the factors of a quadratic equation look like? Are they just numbers?
Negative. The factors of quadratic equations are not just numbers. The factors of quadratic equations are binomials. For instance, x plus 2 or x plus 5.
That's right, V9. Codette, here's one for you. Sometimes we need to turn a factored form quadratic equation into a standard form quadratic equation. To do that, we have to multiply those two factors together, and we use a special technique with a funny name. What is that technique called?
It's called FOIL, which stands for first, outside, inside, last. It's 4 steps of multiplying parts of those binomial factors together.
Excellent. Your turn, Tom. I have a hard question for you.
Hit me, Mr. Caldwell. I'm feeling lucky.
What shape does a quadratic equation make when you graph it? And what do we mean when we talk about the x-intercepts of that shape?
Since this is math class, Mr. Caldwell, I would like to point out that this is actually 2 questions, not 1. But a quadratic equation makes a shape called the paradracula. No, I kid you, it is called the parabola. A parabola looks like a bat that is flying, with its 2 wings that can go upward or downward.
Good. And what are the x-intercepts of a parabola, Tom?
Of course, I do not wish to be rude and answer all the questions. Then nobody else would get to answer any questions.
The x-intercepts are the points on a parabola where it crosses the x-axis. A parabola often crosses the x-axis and then turns around and crosses it again on the way back. So a parabola often has two x-intercepts.
Yes, that is what I was going to say.
That's right. So then, Bones, we said that another name for the factored form of a quadratic equation is intercept form. Why is factored form also called intercept form?
Because it shows us the factors. But the factors also show us where the x-intercepts are.
You're right. Wendigo, can you help me solve an example of that? Suppose I give you the equation y equals x plus 6 times x minus 4. What are its x-intercepts?
The x-intercepts are any number that we can plug in for x that will give us 0 in either of the factors, because this will end up giving us 0 for y. In this example, the number -6 will make the first factor 0, while the number +4 will make the second factor 0. So the x-intercepts are -6 and +4.
Exactly. The places on the x-axis where the parabola will cross are at -6 and +4. And if we use the letters P and Q in our intercept form, we would say that P is -6 and Q is +4. Class, you did a fantastic job today. I'm very proud of you all. We're done with today's lesson, so keep practicing with your quadratic equations, and I'll see you next time.